Hey all, sorry I can't be there today. Just watch this video, fill in the notes that you're given. So the first thing we're going to do is the cheat sheet front and back. Then I'm going to show you some examples, and you're going to try some on your own. Whatever you don't finish does become homework. I am in the building somewhere, so if you need me, go ahead and send me a message on Remind, and I can answer some questions. So the first thing we're going to do is fill out a cheat sheet. The cheat sheet is going to have a bunch of table of values for the different functions, um, and that we're going to be using to transform all of our functions without the use of a calculator. So we know how to graph linear equations, so we're going to start with quadratics. None of the problems are going to be the greatest integer function because we haven't learned that, and that's going to be more for another for later on down the line. So first thing we have is our quadratic. The table of values that you're always going to use, and you'll see how I use them in a later example. It's going to have the x values of -2, -1, 0, 1, and 2. And so if I plug those in, it would give me the y values of 4, 1, 0, 1, and then 4. And this is the parent function, just as a reminder, as the general, what does it look like? So it's that U shape here. The x to the 1/2, or the square root function, is essentially the reciprocal, but really only half of it. We don't use any negative x values, otherwise we would have imaginary values. And as you notice, all of my x values there are perfect squares. So 0, 1, 4, 9, and 16. I'm not going to do -2 to 2 for this table of values. So when you start doing the practice, make sure any of the square root functions you're using this table of values. So the parent function starts at 0, 0 and goes off. It's kind of like half a parabola like this. We can't have the other half of that parabola because otherwise it wouldn't be a function. So again, when you're doing the table of values, you're using this for the square root function. That's what the cheat sheet is for. From there, we have the cubic function. So this is my lovely sketch, the best that I can do on a PowerPoint. We will use the -2 to 2 just like the quadratic. When we plug it in, we get -8, -1, 0, 1, and 8. So those will be the values, and I'm going to do an example with this one for you towards the end. The cube root function, or x to the 1/3, that is reciprocal, not reciprocal, an inverse. What you can see is the x and the y values are switched around. In other words, I've chosen perfect cubes here for my table of values. So anytime we're doing anything with the cube root, we're going to translate these x values, which correspond to the y values of -2, -1, 0, 1, and 2. This is the cube root function, the parent graph of what it looks like. It's very similar to the cubic function, just kind of rotated because it is its inverse. The other one we did, or the next one we did, was absolute value. We also did quartic, but it's very similar to the quadratic, so we're not going to do so many quartics, okay? The absolute value function is the V-shaped. So with this one, we're going to use the -2, -1, 0, 1, and 2. Since it's absolute value, it's all going to become positive. So whenever you do the absolute value functions, you're going to use this table of values, and I'll show you how in just a moment. So if you haven't noticed already, x squared, x cubed, and the absolute value of x are using -2, -1, 0, 1, and 2. The square root function is using perfect squares, and the cube root function is using the perfect cubes. The last one we have is the reciprocal function. It is also known as a rational function. We will do a whole unit on just rational functions in the future. The h value is representing any vertical asymptotes. So for example, in this one, the h value here is 0. So the y-axis is our actual axis here, our vertical asymptote. These guys are getting really close to the y-axis but not touching it. And the k value is the horizontal asymptote, because normally it's the x-axis, and as soon as we include a k, this value is going to shift up and down. Just like if we had an h value, that this asymptote here is going to shift left or right. So the table of values we're going to use for our reciprocal functions are going to go from -2 to 2, but we're going to stick in the 1/2 there just to emphasize what's happening. So we're doing 1 over x. So in this case, for the -2, it's 1 over -2, which is -0.5. When I put -1 in for x, I get -1. When I put -1/2 in, I get -2. At 0, it's undefined. That's why we have an asymptote. And the reason we have ourselves the horizontal asymptote is because that's dealing with, is there a value of y or a value I can put into here that's going to cause this to become 0? And the answer is no, because the top number is 1. And if you're not sure about that, we can talk about that more next block. All right, so 1 over 1/2 is now the positive, so 2, 1, and positive 1/2. Okay, so that is the first side of the cheat sheet. Those are the table values you're going to use to transform if you need them, and you're going to see that in the practice that we do. On the back is just going through the function rules. So this is for any function. So a, b, h, and k have the exact same effect on all of the parent functions. Um, that was one thing I wanted to make sure that I emphasized because some people said it was a little bit different, but everything is exactly the same. For any function, a is going to do the same thing, b is going to do the same thing, and so is h and k. So let's start with the h value. The h value shifted everybody's graph left or right. Okay, didn't matter which function it was, if it was squared, a cube root, square root, absolute value, it takes the graph and shifts it to the left or the right. If this is x minus h, as we saw before, it shifted to the right because h is technically positive. If it's plus h, it's going to shift to the left. The k is up or down, so positive k goes up and negative k goes down. So all that I think everybody understood pretty well, how the h and k values affected the graph. So it's the a and the b that we really want to talk about. A is going to affect your y values, and b is going to really affect your x values here. So let's start off with the negatives. Want to make sure that this is straight as well. So if it's negative, that means we're taking the entire function and reflecting it over the x-axis, because f of x is the same thing as saying y. So we're taking all the y values and changing their sign. So there's a reflection over the x-axis. Some presentations said y, so I want to make sure that a is always the x-axis. However, if it's inside the function, what that means is we're going to reflect everything over the y-axis, because now we're taking all the x values and applying the negative to it first, and it gives us the y-axis, or its mirror image. Other information about a, if a is greater than 1, that's a vertical stretch. If it's between 0 and 1, it is a vertical compression, and you'll be able to see that today. If we're talking about b, it's the opposite. So this is talking about a horizontal stretch or compression. If b is bigger than 1, then it's a horizontal compression. If it's between 0 and 1, then it's a stretch, which is the opposite of what you saw up here. We're going to do a whole day dedicated to b. So to this day's stuff is only going to have a, h, or k in it, or all three. And we'll talk more about b when I'm definitely back in class. So overall, want to make sure you note that the b and the h value are affecting the x values. And we're always using opposites or reciprocals. So the h is always the opposite sign, and b we're going to do the reciprocal. We'll talk more about that later. A and k, though, they affect the value as is. So if a is 2, we're taking all the y values and we're times them by 2. And the k you saw shifted up or down. All right, so now we're on to the packet. We want to fill in. I'll show you how to do a couple, and then I'm going to have you do the best that you can. I'm going to suggest we leave the reciprocal functions for next block if you want. So whatever is not finished except for the reciprocal functions does become homework, okay? So let's start off with the quadratic example. The reason I know it's quadratic is because of the exponent of 2 here. So the parent graph is y equals x squared. That's what you're doing. Now the description means, how am I translating my parent graph using the a, b, h, and k values? So the plus 3 is telling me that the h value is actually negative 3, which means we're going to take our whole graph and shift it to the left 3. Our k value, is negative 2. That means we're going to shift down 2 units. So if I were to graph the parent function, which is this guy here, we're going to take that and use reasoning first, and then I'm going to show you how to do it with the table of values. So what you'll want to start with all of these, except for the reciprocal function, is the point 0, 0. The reason we want to do that is because the only thing that affects 0, 0 is going to be the h and the k. A is not going to affect anything at all. So what I'm going to do is take that point and I'm going to shift it to the left 3, and then I'm going to take it and move it down 2. And that's going to be my very first point for my offspring. Then from there, you can take the other points and do the exact same thing, or you can do reasoning. So normally it goes over 1, up 1. So since there's no a value, we're going to do the same thing. We're going to go over 1, up 1, and it's going to create our next point. The other one goes over 2, up 4. So again, we're going to do over 2, up 1, 2, 3, 4, and here's where our next point's going to land. Then I'm going to repeat that process with the other 2 points. So then I'm going to go do the last point over here, which is to go over 2 and up 4, and then I can plot my, sorry about that, I can plot my last point. So that's the way to do it, through reasoning. We can also do it through a table of values. So this is where the cheat sheet comes in. The 4 or the 2 on the left are the x and y value from the table that you had written down in the beginning. Since the parent function is x squared, we're going to use this set of points here. So then from there, we're going to think, okay, remember, h affects the x value in the opposite way. So what we're going to take is all the x values and we're going to subtract 3. The k value here only affects the y values. So that's going to take all the y values and I'm going to subtract 2. And that's what I'm going to apply to all of my x values. So for example, -2 minus 3 is -5. -1 minus 3 is -4. And I'm going to continue that through the 0, 1, and 2. Then I'm going to repeat this process with the y. So if I plug 4 in, it'd be 4 minus 2, which is 2. 1 minus 2, which is -1. And then continue that process for the last 3 points of y, which were 0, 1, and 4. These points here on the right are the exact same points that I reasoned through that graph there. And increasing, decreasing, domain, and range. Since we've done this for a while, you should be familiar with how that works. Okay, so what I want to do now is show you with an a, where we have a negative a as well, and how to reason through it, as well as how to use the table of values instead. So we're in the cubics, so turn the page into the cubic functions, since there should be 3 examples or 3 practice problems. We have y equals x cubed as the parent function. So the plus 3 is the same thing as the quadratic. We're going to go to the left 3. The -1/4 does 2 things. First of all, the 1/4, since it's between 0 and 1 and it's an a value, it's a vertical compression times a fourth. The negative is, as we talked about with negative a's, means we're going to reflect over the x-axis. So the cubic function normally has these points here, and this is what it looks like. Like I said before, you always want to take the number that goes through 0, 0 and translate that one first, if there is a translation. So this one has a translation of going to the left, 1, 2, 3, so that's what we're going to do first. Then from there, we're going to take the next point. So normally we go over 1, up 1, but so from here we can go over 1, up 1. But however, the distance is no longer going to be 1 because this compression here is by a fourth. So this is going to be compressed down to about 0.25. Then the negative says, okay, I'm going to reflect it, so it shows up there. You can also go from here if you'd like. So this point, if you want to shift it to the left 3 points first, that's fine. So this would go over 1, 2, 3. Then you would reflect it down, and then its distance from the x-axis would be compressed by a fourth. So let's do this one here. If I go over 1, 2, 3, then I'm going to reflect it down, so that would go down to -8, and then I'm going to compress its distance. Normally it has a distance of 8 from the 0, 0 point or from the x-axis. When I multiply that by 1/4, it's only going to go now to 2. And I'm going to repeat that process with the other 2 points. And I would have my new graph. Now some people struggle through this for a little bit, so instead we can use this table of values. Now we're using the cubic table, which is still -2 to 2, but our values for the y is -8, -1, 0, 1, and 8. The x values are affected by h. Since it's a +3, the actual h value is -3. So we're going to take all the x values and subtract 3. That's the shifting of everything to the left. For the y values, we're going to do it times -1/4. So what that does is take care of the reflection and the compression. So all of these x values here, we're going to subtract 3. So -2 minus 3 is -5, -1 minus 3 is -4, and so on. Now I'm going to take all of my y values here, so netless, for example, -8, and I'm going to times it by -1/4, which gives me 2. -1 times -1/4 gives me 0.25. 0 times that is 0. Then 1 times -1/4 is -0.25. Okay, now it's fixed. So -0.25, and 8 times -1/4 is -2. So again, I use the a value times y. If there was a k value here, say there was a +3, it would be -1/4 y plus 3. So then from there, to describe it, we have no increasing in the translated function. It is always decreasing. The domain and range are both -infinity to infinity. So hopefully this was a good start. Like I said, you can go through the rest of the packet for the rest of the block. But again, the reciprocal functions, you can wait until next class. We'll talk about those. Either reason through it like I was talking about it, or use the table of values. Either method works. Whatever you don't finish becomes homework. And then we'll do the last presentation on Friday. Again, if you have any questions, if you're unsure about something, make sure either 1, you're working with someone, or 2, shoot me a message on Remind, and I will see you next class. Have a wonderful day.